Today I discuss one important topic related to system of linear equations. Okay, we also know that the system of linear equations ax equal to b. Okay, in that means m linear equations in n unknowns. Okay, in unknowns m linear equations. Okay, m linear equations in n unknowns. This one happened. Understood? Ax equal to b. Then now we also discuss this theorem. Okay, that means solve. We also solve it by how? That means by Gaussian elimination method. Okay, and we also known about that Gaussian elimination method. That means step by step we also forward to the required solution. Okay, that means then we also now going to discussion if solve this system. Okay, then what we get? Okay, mm, then an arbitrary solution of the form, an arbitrary solution is of the form each of the form is equal to s0 plus t1 u1 plus t2 u2 plus dot tn minus r un minus r. Okay, where r is the number of non-zero rows, where r is the number of non-zero rows, number of non-zero rows. Okay, in a dash where r less than equal to m. Okay, and then the preceding equation is called a general solution of the system ax equal to b. Okay, the preceding equation. Okay, the preceding equation is called a general solution. It's called a general solution. Okay, it's called a general solution of the system ax equal to b. Understood? Preceding equation is called a general solution of the system ax equal to b. Okay, so this one is equal to s0 plus t1 u1 t2 u2 tan minus r un minus r, where r is the number of non-zero rows. Okay, in this augmented matrix, that means a dash, we getting a dash. Okay, and b dash, then obviously this one is a dash. Okay, that means row reduced ab is row reduced equivalent from a dash to b dash. Okay, row reduced equivalent form. Okay, then what happened? Then this a dash have r non-zero rows, so we write it in this way. Okay, that means some general solution. Then what happened? It express an arbitrary solution is of ax equal to b in terms of n minus r parameters. Okay, then it express an arbitrary okay, an arbitrary solution is of ax equal to b in terms of in terms of n minus r parameters. Okay, in terms of n minus r parameters. Okay, then what happened? Then we're going to discussion one related theorem. We erase that portion and going to discussion on one related theorem of that topics. Okay, theorem we write here. Okay, let ax equal to b, let ax equal to b be a system of r non-zero, be a system of r non-zero equations in n unknowns, non-zero equations in n unknowns. Okay, and suppose that rank of a equal to, suppose that rank of a equal to rank of a augmented b. Understood? Okay, and that a augmented b, okay, is in reduced row, is in reduced row equivalent form. Then what happened? Then, okay, then first we write it here, a rank of a equal to r, and second option b. Okay, option b, if the general solution, if the general solution obtained by procedure, by general solution obtained by procedure above is of the form, by some procedure is of the form, is of the form is equal to s0 plus t1 u1, here t2 u2 plus dot dot dot, okay, tn minus r un minus r. Understood? Then what happened? Then u1 u2 dot 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 un minus r is a basis, is a basis, okay, for the solution set, for the solution set, okay, of the corresponding homogeneous system, of the corresponding homogeneous system, of the corresponding homogeneous system, and S0 is a solution to the original system, and S0 is a solution, okay, to the original system, to the original system. Understood? Okay, now we're going proof of that. We erase that portion. Now we're going to prove of that. Now we write proof. Okay, since A augmented B is in reduced row equivalent from is in reduced row equivalent from, then what happened? Then that means A augmented B must have R non-zero rows, non-zero rows. Okay, clearly these rows are linearly independent. Clearly these rows are linearly independent. Okay, then what happened? Independent of the reduced row equivalent form of the reduced row equivalent form, and so rank of A augmented B equal to R. Understood? Thus rank of A equal to R. Not a problem at all. Okay. Now K be the solution set for Ax equal to B. Let K be the solution set for Ax equal to B. Okay, and let Kh be the solution set for Ax equal to 0. For Ax equal to 0, then what happened? Here setting t1 t2 dot tn minus r equal to 0, we see that is equal to s0. Okay, belongs to K. Then K equal to s0 plus kh. Okay, then K equal to s0 plus kh, and hence here kh equal to difference is 0 plus k equal to span of, okay, span of u1 u2 un minus r. Okay, then what happened? That means rank of A equal to R. We erase that portion and going to further discussion of that. Okay, then what happened? Then we also show that, okay, then obviously we show that because rank of A equal to R, okay, and we have dimension of okay, kh equal to n minus r. Okay, now thus since dimension of kh equal to n minus r, okay, and kh is generated by a set, and kh is generated by a set okay, u1 u2 un minus r containing at most, okay, containing at most n minus r vectors, okay, containing at most n minus r vector. Then what happened? That means k is generated by a set u1 u2 un minus r and containing at most n minus r vector. Then what happened? Okay, then we conclude that we conclude that okay, this set is a basis for kh. This set is a basis for kh. Okay, understood? That means we also discuss this one, rank of a equal to r. Okay, but now we have rank dimension of kh equal to n minus r, and obviously k is generated by this set, so obviously this set is a basis for kh. Okay, then we also write this one is a solution set. That means s equal to s0 plus t1 u1 t2 u2 tn minus r un minus r. Okay, this one be a solution set. Understood? Not a problem at all. Okay, so now we also, that means, discuss an interpretation of reduced row echelon form. Okay, we also discuss now, we erase that portion and obviously discuss this one. Okay, we write it now here, an interpretation. Okay, an interpretation of the reduced row echelon form, of the reduced row echelon form. Understood? We also discuss now. Okay, then obviously we write it in this way, let A be an m cross n matrix. Okay, and with column a1 a2 an. Okay, and B be the reduced row echelon form, and B be the reduced row echelon form of A. Okay, Then B, denote the columns of B by this one. Denote the columns of B by B1, B2, dot 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 Bn. Okay. Then if rank of A is R, if rank of A is R, then rank of B is also R. Okay. Then what happened? That means B is row reduced echelon from, and no non-zero row of B can be a linear combinations of the other rows of B. Okay. Then what happened? Then so we write it now because okay, because B is in reduced row echelon from. Okay. Then what happened? No non-zero row of B, no non-zero row of B, okay, can be a linear combination of, can be a linear combination of the other rows of B, of the other rows of B. Okay. Hence B must be exactly R non-zero rows. Hence B must be, okay, exactly R non-zero rows. Exactly R non-zero rows. Okay. Then what happened? If R greater than 0, then the vectors must occur among the columns of B. Okay. We erase our portion and going to further discussion of that. Okay. Now what happened here? That means if R greater than 0, if R greater than here 1, the vectors u1, e2, er, the vectors, okay, u1, e2, dot 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 er must occur among the columns of B. Must occur among the columns of B. Okay. For I equal to 1, 2, dot 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 r, for I equal to 1, 2, dot 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 r, let's say R denote a column number of B such that for I equal to 1 to R, let's say R denote, okay, a column number of B such that denote a column number of B okay, such that Pji equal to ei, such that Pji equal to ei. Okay. Now we claim that aj1 dot 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 ajr, the columns of A corresponding to these columns are linearly independent. Okay. Now we claim that okay, aj1, aj1, okay, aj2 ajr. Okay, the columns of A, the columns of A corresponding to these columns of B, corresponding to these columns of B, columns of B, okay, are linearly independent, are linearly independent, okay. For suppose that they are scalar, okay, for suppose that there are scalars, okay, c1 c2 cr, c1 c2 cr, such that c1 is a1, c2 is a2 cr is ar equal to 0. Understood? Then what happened? Then obviously we write it, because B can be obtained from A, because B can be obtained from A, okay, by a sequence of elementary row operation, by a sequence of elementary row operation, sequence of elementary row operation, okay, by a sequence of elementary row operations, there exists an invertible M cross M matrix, there exists an invertible M cross M matrix, okay, M cross M matrix, invertible M cross M matrix M, okay, such that MA equal to B. Understood? Then multiplying the preceding equation by M yields, multiplying the preceding equation okay by M yields, okay, C1 M aj1, C2 M aj2 here CR M ajr equal to 0. Understood? Since M aj aji equal to bji equal to ei, okay, it follows that what happened, C1 E1 C2 E2 CR ER equal to 0. C1 E1 C2 E2 CR ER equal to 0. Okay. Hence C1 equal to C2 equal to CR equal to 0. Okay, and proving that the vectors are linearly independent, and proving that the vectors aj1 aj2 ajr are linearly independent, linearly independent. Okay, now we also write here, because B has R non-zero rows. Okay, because B has R non-zero rows. Okay, and every column of B has the form, and every column of B every column of B has the form, okay, d1 d2 dr, d1 d2 dr 0 0 0. Understood? For scalar d1 d2 dr, for scalars d1 d2 dr. Okay, the corresponding column of A must be, we erase lower portion and going to further discussion of that. Okay, the corresponding column of A must be, the corresponding column of A must be, okay, M inverse here T1 E1 D2 E2 plus dr ER, okay, equal to T1 M inverse E1, okay, D2 M inverse E2 dr M inverse ER, okay, and this one equal to here T1 M inverse Bj1 plus T2 M inverse Bj2 dr M inverse Bjr equal to what? Equal to D1 Aj1 D2 Aj2 dr Ajr. Understood? In this way, we also, that means, discuss the corresponding column of A. Okay, we also, that means, gives an interpretation of the reduced row equivalent form. Okay, so today I stop here. Okay, if you get this type of videos, please subscribe my channel, and if you have any questions, comments, suggestions, write it in comment box, and if you want to give like, please click on like option. So today I stop here. Thank you.